Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 170. The very first problem on page 170. Let's turn to it. On page 170, in problem number 126, they tell us that we have an arithmetic sequence. They use the term sequence. I'm calling it series. It's the same thing. Sequence, series, whatever it is, it's the same thing. So we have an arithmetic sequence here, P, R, S, T, and U. We are told that is an arithmetic sequence. It's an arithmetic series. What is an arithmetic series? An arithmetic series is where each term after the first term is equal to the preceding term plus a constant. For example, each term after the first term. The first term is an exception. That's your starting point. And starting point can be any number. For example, you may start out at 3. And then each term after the first term is going to equal the preceding term. So for term number 2, the preceding term is 3 plus a constant, whatever the constant happens to be. For example, each term after the first term is the preceding term, which is 3, plus a constant. Constant here is 2. This is your constant. And that constant, of course, is so called because it's constant. Each term from now on is going to go up by 2. So 3 plus 2 is 5, which means the one after that is going to be 5 plus a 2. 5 plus 2 is 7, so the next one is going to be 7 plus a 2. And so forth, and so on and so forth. Basically, what we have built here is a consecutive odd integers, and that's an arithmetic series. Why is it an arithmetic series? Because no matter where you start your series, it doesn't matter where you start your series, but once you've begun your series, each term after the first series goes up by the same constant amount each time. And in the case of consecutive odd numbers or even numbers, it goes up by 2, obviously. Here's another one. We may start out at 2, and then we're going to add, so we take the preceding term and we add a constant. This is our constant. So that's our new term, 7. Next one is going to be 7, which is the preceding term, 2 plus 5, that's 7, plus the constant, which is 5. So now in this series, each time is going up by 5. The one after that is going to be 7 plus 5 is 12, plus a 5, and so on and so forth. So in the second example, they're going up by 5 each time. This is starting at 2 and it's going up by 5. Let's take a look at one more here. It begins with negative 7. And it's going to go up by 3 each time. The first time around it went up by 2, then it went up by 5, now let's increase by 3. So negative 7 plus a 3, that's our second term. So each term after the first term, this is the first term, each term after the first term equals to the preceding term. In the case of the second term, the preceding term is negative 7 plus a constant. Constant here is positive 3. Negative 7 plus a positive 3 is negative 4 plus a 3. This is your constant. And negative 4 plus a 3 is negative 1, so the one after that is going to be negative 1 plus a 3. And so on and so forth. This is again your constant. And all of these are 3 arithmetic series. These are 3 examples of simple arithmetic series. Now if you were to take any one of these series, let's call it the old series. Let's take this for let's take the very first one here. So our old series was 3, 5, 7, 9, so on and so forth. And if you were to multiply it by 2, if you take our old series and double it, in other words, if we take your old series and multiply each entry by 2, we end up with 6, 10, 14, 18, and so on and so forth. The question is this new series that we created, is this series also an arithmetic series? To find out the answer to that question, we simply have to look at the difference between each adjacent terms. And as long as the difference is the same, if the difference does not vary from term to term to term, if the difference stays the same, then it's an arithmetic series. For example, here, the difference between these two terms is 4. Difference between 10 and 14 is 4. Difference between 14 and 18 is 4, which should not be a surprise to us at all, because the difference before was 2. If the difference were 2, and if you multiply the old series by 2, then obviously new difference is going to be 4. But the point is, the difference is constant. It doesn't matter. It doesn't matter the fact that now the difference is different from before. Of course, it's different. That's the whole point. If the difference were the same as before, it wouldn't be a new series. It's a new series with a difference of 4. But because the difference is constant, it is also an arithmetic series. So multiplying an arithmetic series by 2 does not change the fact that it is still an arithmetic series. Statement 1 is correct. Let's see how the question is phrased. It says, if the list of letters shown above is an arithmetic sequence, which of the following must also be an arithmetic sequence? And in the first statement they tell us that is 2 times p, 2 times r, 2 times s, and so on and so forth. They're multiplying each term by 2. And we just found out all it is going to do is that it's going to multiply the difference by 2, but it's going to remain arithmetic series, which means the correct answer, whatever it is, must contain Roman numeral 1 in it. It must contain Roman numeral 1 in it, which means we can cross out B. B says 2 only. We can cross out C. It says 3 only. And we can cross out E, which says 2 and 3. Let's look at the second one. In the second one, all we are doing is subtracting 3 from each term. So if we have our old series, let's use a different one now. Let's use this one here. So our old series is 2, then 7, then 12, and then 17. This is our old series now, with the difference of 5. As you can see, the difference of 5. As long as the new series also has the same constant difference, not the same difference as before, obviously, because as I already pointed out, if the difference were same as before, it wouldn't be a new series. It would be the same series as the old one. So let's subtract from it. So it's old minus the 3. So 2 minus the 3, 2 minus the 3, it becomes negative 1. 7 minus the 3 becomes a 4. 12 minus the 3 becomes a 9. And 17 minus the 3 becomes a 14. Let's see the difference. Difference here between negative 1 and 5 is still 5. Negative 1 and 4 is still 5. The difference is 5. And the difference is 5 again. This is a 14. Why is difference same as before? Because unlike this situation, in the first situations where we multiply each term by 2, which means we doubled everything. We doubled the series. If we double the series, the difference is going to be double. In the second scenario, all we are doing is we are picking up our series. It's the same series. Think of it as literally, physically picking it up. We're picking it up and we are shifting it by 3 units. Shifting it by 3 units is the same as subtracting 3 from each entry. Because we are shifting the entire series by 3 units, the series itself does not get changed. It's the same series. The difference between the adjoining terms, not adjusting terms. The difference between the adjoining term, the neighboring term, is still going to be the same as before, because it's the same series. We just simply have picked it up and shifted it 3 units. Had we picked it up and shifted it 5 units to the right, everything would have been 5 more, which we would have added 5 to each, but the difference would have been same. So this is also an arithmetic series, because the difference is constant. Not because the difference is the same, difference is constant. Which means the correct answer, whatever it is, must also contain Roman numeral 2 in it. Since we're down to 2 answer choices, obviously we're going to rule one out. So now answer choice A is gone, answer is D. Which means series 3 does not work. And we're going to see, just for learning purposes, we're going to actually see why series 3 does not work. Let's do it right here. For number 3, I'm going to give you an example of a very simple one here. Let's go back to the first one here. Here's our old series, which was 3, 5, 7, 9, so on and so forth. And here we are taking our old series and squaring it. That's what we're doing in the third option, is squaring each term. So this becomes 9, this becomes 25, this becomes 49, and this becomes 81. You can immediately see the difference is not going to be constant anymore. Difference between 9 and 25 is 16. Difference between 25 and 49 is 24. That's it. We don't have to go anymore. It doesn't matter what happens. The difference is not the same. Since the difference is no longer the constant, if you take the old series and square each term, it is no longer an arithmetic series. It is no longer an arithmetic series because it does not go up by constant amount each time. It has to go up by the constant amount each time. That's what makes it an arithmetic series. An arithmetic series starts out with wherever you want to. The first number is up to you. You pick one number at random, and then after that, each term after that goes up by a constant amount. If it does not go up by a constant amount, it is not called an arithmetic series. 3 is not an arithmetic series. The original one was, but when you square it, it is not an arithmetic series, which is why the answer is D. Alright? I'll see you tomorrow, okay? Bye now.